So in our last class, we have discussed about stopping sight distance. So today we will discussing about overtaking sight distance. So in the overtaking sight distance, if you go for the definition of the overtaking sight distance, then the definition is the minimum visibility required for a driver to overtake a slow moving vehicles. So if you consider about the different factors which are important for the overtaking sight distance, these factors are speed of the overtaking vehicles, that which vehicles is trying to overtake another vehicle. So therefore another factor is important, that is speed of the overtaken vehicle, that is the speed of the lower speed vehicle, and speed of the any other vehicle which is coming from the opposite direction. So that speed is also required, because other than the overtaking vehicles cannot perceive the situation, and some head-on collision or some accident may happen. Then skill and reaction time of the driver. So in that case, if the reaction time of the driver is less, he can overtake very easily, he can take the decision. So that is the important factor. Now in the case of overtaking sight distance, the reaction time of the driver is considered as 2 seconds. Then distance between the overtaking vehicles and overtaken vehicles. Then rate of the acceleration of the overtaking vehicle, that how much rate of the acceleration of that overtaking vehicle is, because if the rate is higher, in that case that overtaking vehicle can get to a higher speed with lesser time. And if there is any gradient, so what is that gradient, whether it is a positive gradient or negative gradient. Now this is an ideal scenario for that overtaking distance, side distance considerations. So basically it is a two-lane two-way road. So in that road, this A, B and C are three vehicles. Vehicle B is the overtaken vehicle, vehicle A is the overtaking vehicles, and vehicle C is the vehicles coming from the opposite direction. Now A1, A2, B1, B2, A3, C1, C2, etc. are the different position of these vehicles in different time frames. Now, what happens in that overtaking operation? First, vehicle A, suppose that vehicle A is coming with a design speed and vehicle B is moving with a slower speed. So, when that vehicle A first try to overtake the vehicle B, in that case, initially, he will perceive the situation. He will look for any other vehicles which are coming from the opposite direction. He will perceive that what is the speed of the vehicle B and how much acceleration he have to provide so that he can easily and safely overtake the vehicle B. So within that thinking process, he will simply follow the vehicle B, reducing his speed, and that speed would be equivalent to the vehicle B. So after reducing that speed, then he will follow vehicle B for some times, and that following would be within that reaction time. So after that, what will happen, that vehicle A will accelerate, change its lane, cross that or overtake the vehicle B, and again move to its original lane. So basically this total portion from A2 to A3, that is the total overtaking operation, and within that time vehicle C will coming from C1 to C2 position. So if we want to divide this overtaking distance, in that case we can divide this into three equal parts. First one is D1, that is when that vehicle A moves from position A1 to A2 within that reaction time with reducing speed. Okay, then D2 is the actual overtaking operation, that is vehicle A will overtake that vehicle B, that is D2, and D3 is the distance covered by the vehicle C from C1 to C2. So that is basically three parts of that overtaking side distance derivation. Now again, if you consider the D2, when vehicle A will follow the vehicle B, he always maintain a safe distance or clear spacing from the vehicle B. That clear spacing is denoted as S, and it is basically 0.7 VB plus 6 by empirical formula. Now after it overtake the vehicle B, then also it will maintain a clear spacing between vehicle B and A, and that is basically S, or S equal to 0.7 VB plus 6. So your D2 is basically here, if you consider this distance from B1 to D2 as V, then it is basically V plus 2S. Now another thing is then D2 distance is covered by vehicle A from position A2 to A3 within, suppose, a overtaking time capital T seconds. So capital T is nothing but the actual overtaking time. Now within that time vehicle B will move from B1 to B2. Okay. So let us go for the detailed analysis of the overtaking side distance.
So,
Yes.
S is constant.
Which
It is
S,
like fixed.
yes, S is given by the empirical formula 0.7 VB plus 6. So basically the value of the S will be depending on the speed of the overtaken vehicle. Okay, so I will explain this. First come to the derivation portion, then I will explain this each and everything. So as we have discussed that our overtaking total distance is divided into three parts, that was D1, D2 and D3. So that portion I have discussed. Now coming to the next portion, this A1 to A2. So initially the speed of the, before reaching to that position A, initially suppose the speed of that vehicle A was V meter per second. Okay, V meter per second, and suppose that is the design speed, and with the same design speed suppose vehicle C is also coming, and the speed of the vehicle B, which has lower speed, suppose the speed is V suffix B meter per second. Okay, now the thing is from A1 to A2 that distance would be covered within the reaction time. Okay, suppose that reaction time is T second. Suppose that reaction time is T second. So in that case, your A1 to A2, that total distance would be VB into T second. Now here T is considered, that value is constant, and it is considered as 2 seconds as per the recommendation from the code. So your VBT is nothing but 2 into VB. Okay, it is 2 into VB. Now what happens after that, that vehicle A will follow the vehicle B, okay, and maintaining a clear spacing. So that clear spacing is denoted as S, and the value of S is equal to 0.7 into VB plus 6. So basically that's S, the value of S will be depending upon that this value, okay, the speed of the overtaken vehicle. So value of S will be depending on this value. So basically that value is not constant, but it will change depending on the speed of the overtaken vehicle. So your D equal to nothing but D equal to your D2 equal to nothing but B plus 2S. Now you know what is the value of S. Okay, now another thing is initially the speed of the vehicle A at A2 position was was VB. At that point, the speed of the vehicle A was VB. It's reduced speed. So after that, when that overtaking operation will take place, in that case, he will accelerate. Okay, accelerate, suppose with a rate of a meter per second square. Okay, it will accelerate, and after accelerating, it will move to position A3. So your total d2 distance is Vb. Now, if t is the total time taken from position A2 to A3, Vbt plus half into A into t square. Okay, this basically that is basic equation, and I think you are familiar with this equation from your 9 or 10 standard. So basically d2 is nothing but vbt plus half at square. Again, you know that d2 is nothing but b plus 2s. So your b plus 2s equal to vb into t plus half a t square. Okay, now again another thing, that b is from here to here. Okay, so basically that is the distance covered by the vehicle b during that overtaking operation, or during that total time t second. So basically here b is nothing but vb into t. So you can write vb t plus 2s equal to vbt plus half at square. So here VBT and VBT will be cancelled out, and you will got the value of t, that is the time, equal to root over 4s by a. Now all these parameters are known to you. What is the value of A? That would be given. What is the value of S? You can easily find out from the formula, that is S equal to 0.7 VB plus 6. Now only unknown was total overtaking time. Now that is known to you. Using that formula, you put all these value into D2 and you will find the value of D2. Now another thing, coming to the next portion, that is from C1 to C2. Okay, from C1 to C2. Now from C1 to C2, that distance was covered by vehicle C, and total time taken for to cover that distance is nothing but the total overtaking time. Okay, so if the speed of the C is v meter per second, in that case your d3 distance is v into t meter. Okay, so that is your total overtaking side distance. Now remember one thing, whenever some problem will be there, numericals would be there, and you have to find the overtaking side distance. In that case, if speed is given as kilometer per hour, in that case first your task is to convert all the speed values into meter per second, because all of your formulas are given specifically into meter per second. So therefore it is needed to convert your speed values into meter per second. Okay, so these are the thing which is written over here. So this is the total overtaking side distance. Now another important thing is overtaking zone. What is overtaking zone? So in the highway, we suppose it is not possible to provide adequate overtaking side distance at each and every location. In such cases, it is recommended to provide some overtaking zone or some allocated positions where vehicle can overtake. Okay, where overtaking operation could be taken place. So basically, from this picture, these are the portions where overtaking zone is denoted. So in this portion, as the width of the road is higher, in such cases you can overtake any other vehicle in these cases. Okay, now there is some minimum and desirable length criteria for the overtaking zone. Now the minimum length for that overtaking zone is 3 times of the overtaking side distance. So if it is asked to find out what is the minimum distance of the overtaking zone, so in such cases first you have to find out what is the overtaking side distance, and after that you have to find out what is the minimum overtaking zone, and the desirable overtaking zone length would be 5 times of the overtaking side distance. Now you have provided that overtaking zone in a particular highway. Now your task is to inform the driver that a overtaking zone is ahead of them. So in such cases, if you want to inform them, you need to install some informatory sign before entering that overtaking zone. So how to install that sign, or where to install that signpost? Okay, so first thing, suppose that vehicles are moving in this direction. So in that case, your first signpost would be at a distance of overtaking side distance from that overtaking zone. Okay, so suppose your overtaking side distance is 100 meter. So your first signpost would be at a distance of 100 meter from the entry point of that overtaking zone. After that, he will overtake that vehicle, and again when he is leaving that overtaking zone, there would be again another signpost indicating that overtaking zone is near to complete. Okay, and overtaking zone is near to finish. So in such cases also a signpost is required. So another signpost is required which would be at a distance of overtaking side distance from the end point of the overtaking zone. Similarly, for the vehicle moving in that direction, there would be signpost like that. Okay, now let us solve some numericals. So, is it clear to you?
Sir,
Yes.
we have to write this question.
Just check the questions. You have to solve this. First, tell me whether that overtaking side distance derivation is clear to you or not. Is it clear?
Sir,
Okay. So just write down like that. Your V is given as V equal to 70 kilometer per hour. Okay. Just write it down. V equal to 70 kilometer per hour and VB is given as 40 kilometer per hour. And your acceleration is given as 0.99 meter per second square. So you have to find out what is the overtaking side distance. Now the thing is, what first you have to do is you have to convert the speed values into meter per second. Okay, convert the speed values into meter per second. Okay, do one thing. I am now ending the meeting. Please re-log in the meeting with the same link. Okay, otherwise it will be closed soon. I am ending the meeting. You just re-log in with the same link.